In this program, we'll use a turn knob to control the brightness of an LED light. In the void setup function, we'll use pin mode function to set port A2 as an input. This is where the turn knob is going to be plugged in on the smaller block of ports at the bottom of MakerBoard. Make sure the center leg is plugged into port A2, but it doesn't matter which outside leg is plugged into plus and which one's plugged into minus. You'll use another pin mode function with the arguments 6 and output for your LED. Because we're using the analog write function in this program, you need your LED to be plugged into port 3, 5, 6, 9, 10, or 11 for this to work correctly. Within the void loop, we're going to create a variable. This variable is an integer type, which we shorten to int, and that means it's a whole number with no decimal places. The name of the variable is brightness, because that's what this is going to stand in for, the brightness we're sending via analog write to port 6. The value of this variable is going to be created from the reading from the turn knob. The turn knob can send values into the code from 0 to 1023, depending on how far it's twisted. Analog write can use values from 0 to 255, 0 for completely off and 255 for maximum brightness. So what we're going to do is take the analog read of port A2, or take the sensor reading from the turn knob, and divide that by 4, because 1023 divided by 4 is 255. So it's right there at the maximum brightness we can use for analog write. So again, we're creating a variable that is an integer, giving it a name of brightness, and giving it a value of analog read A2 divided by 4. The only other line of code that's going to run in the void loop is an analog write function. The analog write function has two arguments. First, the port that we're analog writing to, and second, the value we're sending via analog write. This can range from 0 to 255, and in the past, we've used an exact number here, like 120, to turn on the LED light partially. Instead, we're going to use a variable value here, and that variable value comes directly from the value the turn knob is sending into the code. In previous projects, we've often created the variable above the void setup. The reason that we're creating this variable inside the void loop is because the variable value needs to get updated every time the void loop runs. So every single time that the void loop runs, we want to take a new reading from port A2, divide that by 4, and then immediately use that value in analog write. So because there are no delays in this code, and we're updating the variable every single time the program runs, you can twist the turn knob back and forth and get a really responsive brightness on your LED.